Hello, everyone, and welcome to episode 39 of the FusionCast. We have a special episode today where we're going to be talking about a topic that we have been talking about a lot lately, which is, of course, watsonx. We have a special guest joining us today, Vasily Tarasov from the CIO's office. Vasily, welcome to the program. We appreciate your joining us. And Vasily brings a great perspective on this. So as in his role, he has been involved in the deployment and the sort of, merging together, I guess, of watsonx and Fusion. So, for our audience, primarily focused on Fusion, we thought it'd be a great opportunity to talk a little bit about the work internally at IBM within the CIO's office to bring those things together, kind of what your experiences have been, what some of the things are that you've learned, and how we can sort of help enable our sellers and equip our sellers with some of that knowledge. So Vasily, again, thanks for joining us.
Yeah, no, definitely. Thanks for having me. Just a small correction here. I'm not from the CIO office. I'm from the research division.
Oh,
But
okay.
indeed,
Sorry.
I think you're absolutely right that the work was recently demonstrated to the CIO office. And the work was driven by the IBM Storage CTO and the research. So I think hopefully I still will be able to provide enough interesting material here.
I have no doubt. Okay, cool. So under the sort of guidance of Vincent and that team sort of working with this environment. So tell us a little bit about the process. Like over the last couple of quarters, I'm sure you've, been engaged and involved in a lot of this kind of what has been the workflow, I guess, in terms of bringing watsonx in and doing the deployment and what are some of the things you've learned as part of that process?
Right. So we started to work on this project in the very end of 2022 and more actively in the beginning of 2023. And at that time, interestingly, Watson X dot something wasn't even as common, right, or as known. But the technology that was understood to be, very dominant and very useful in the future is the Lakehouse, right? And so one of the core components of watsonx.data is actually Lakehouse technology built around Presto. So in the beginning of the year, we actually worked on, hey, how do we run Lakehouse and Presto specifically on top of Fusion HCI in future? What kind of value proposition that is going to get, and what technologies should we use internally, right? And so you probably know, or maybe your listeners know, that inside of a Fusion HCI, one of the storage systems that's used is Spectrum Scale, or IBM Storage Scale nowadays. And it has a few unique capabilities specifically in that area, right? So one of the technologies there called AFM, Active File Management, allows to bring the object storage transparently into the file system, into these local, really fast devices. And then whatever software you run inside of Fusion can access those files or objects also much faster than directly from the storage. So our thinking was around that capability of scale, and it sounds like it fits really well the use case. And that's how we started the design and then already the implementation.
Cool. And so what was the first phase? I mean, did you do some pilot testing or some kind of individual, test environments initially on an HCI system? I think this was happening in Almaden or in SVL, right?
So the majority of the initial work, right, was done by the CTO office, and then we joined at a little bit later stages. And so during those phases, what needed to be done is to actually understand what is Presto, right? How to run it in a containerized way on Fusion and on Fusion HCI. And then if you look at that stack, it's quite complicated. There are many components in that stack. There is Presto. Now it needs to talk to the object storage protocol, but then in Fusion right now, we don't have object on top of scale. So we had to enable this component called Nuba, which is part of ODF, make sure that it actually runs on top of scale, and within scale, configure file system and the file sets internally with AFM technology enabled so that it can actually access slower storage wherever it is. So the very first phase was just proving that the whole stack functionally can work together and you can issue in the end the queries to the Presto. Now, another question, of course, was what kind of queries, what kind of data sets to use in our experimentation. And so the work was initially focused on kind of a famous benchmark called TPC-DS, right?
Mhm.
That's a benchmark for SQL databases. And so we can reuse it for generating queries against Presto, and it comes with a data set. And so that was the decision made at that point. And what was also important at that stage is to demonstrate that storage, matters, right? That for this kind of use case, for this kind of workload, it is data intensive enough to create the bottlenecks on the storage. And indeed, this is the case, and especially as the data sets will continue to grow, and within those data sets, you will continue to have with working sets, kind of these hot areas that you really want to transparently bring closer to compute. So we were able to demonstrate indeed that Lakehouse and Presto have these kind of properties. So that was the very first phase.
Mhm. Cool. And then subsequently, I know you guys did a fair amount of additional benchmark and performance testing. And were you comparing that environment to other environments for the purposes of performance benchmarking, or?
Yeah, that's a very good question. So it's both the benchmarking, just understanding the properties of the performance in this environment, but also tuning, right? So
Hmm.
because there's so many layers and each of it has a lot of parameters that you can configure, but also even some of the internal configuration, internal interesting ways to configure it that are not exposed to regular customers. And so once we were analyzing how the system behaves under load, we were constantly optimizing it to try to get as good or the best performance we can get it out of it. So that was one thing. And the second one is the comparison. What's our baseline, right? So the baseline, of course, I think the situation that we always were keeping in mind was the following. We come to customer side and the customer has lots of data in the local relatively slow storage,
Mhm.
right? So old object storage or old HDFS cluster. And I use here the old to demonstrate that, frequently it's not that the technology itself is slow, it's just that it's a previous generation of the technologies. Hardware got better, software got better. So
Mhm.
now you have a lots of data locked into these older storage silos, but you still want to do analysis against it. You still want to run queries against it. And so this is where Fusion HCI with Presto comes in and accelerates your access to that data. So our baseline, of course, is just what if you just run Presto without any acceleration, maybe still on Fusion HCI, but the requests, puts and gets, they go directly to your old object storage. That's the baseline.
Mhm.
And the demos, you mentioned a few. One of them was at Think 2023, showed that we can improve performance 7 times. And the demonstration of the CIO use case, I believe the improvement, if we converted the data into the iceberg format, was even 80 or 90 times. So tremendous improvement in the
Wow.
performance, right? And so other comparison points that are, I cannot talk fully about what are the outcomes there are competitors. So one common one is the Alexio. And so Alexio is kind of an accelerator for example,
Mhm.
for the Lakehouse that also relies on the local storage like we do. And we have a lot of functional benefits compared to Alexio. We
Mhm.
provide the global namespace, we have durable cache, etc. I'm sure performance numbers were also collected, but I just won't remember them from the top of my head.
Yeah, no problem. So those are pretty non-trivial performance improvements, I would say. So Pete, I was thinking that as Watson X is rolling out and sort of the wave is building, Red Hat OpenShift data science is also kind of building to a crescendo at the same time. It feels like maybe there's some cross-pollination opportunities here. I mean, you know more about it than I do, but
Yeah, for sure. There definitely is. And if you're not familiar, I think it's called Rhodes, Red Hat OpenShift Data Science, RHODS. Feel free to go check it out. It's essentially a suite of tools, to help you not just with data analytics, but with machine learning also. And yeah, there's been a lot of work that's done, obviously, with ODF, but also, with Fusion, around, making sure that those two solutions work. I wanted to point out one of the things, though, that Vasily mentioned that I think is really important about this entire solution about watsonx.data. It's, all the cool new generative AI things, that are contained there, even, a lot of the new formats, the Parquet formats, are really moving the industry forward. And what he's talking about, when referring to HDFS and Hadoop, we're moving from a world which had a very tightly coupled architecture. And the problem with that architecture, as Vasily pointed out, is, locking in data, not having data mobility, those types of things. But the other problem with it is the tightly coupled nature of the architecture and the coupling of the compute and the storage together. You can't grow one independent of the other. Now, with this new solution with our data lakehouse, we're kind of at the other end of the spectrum, and we're giving complete freedom for the data to exist anywhere globally. And that's the beautiful part of AFM, is to create that global namespace and to free, to move towards a very loosely coupled architecture, which is going to deliver certainly a lot of performance benefits, as he talked about, but certainly I think a lot of financial benefits for our clients too.
Yeah, for sure. I mean, it's like this increased disaggregation and the ability to compose the infrastructure to suit the workloads more specifically and more precisely, which is amazing. And I think so. Vasily, from your perspective as a researcher in this space, is that kind of where you see it going? It feels like it's moving towards a fully disaggregated, true hybrid cloud, on-prem pieces sitting in the cloud with seamless, data mobility between the two. I mean, is that fair? I mean, is that where you kind of think things are going?
No, definitely. I think this is the only answer to this large number of data sources of different formats that exist, right? So if you look at the Presto source code, for example, and if you look under, plugins directory there, it's a huge number of data sources and data formats that it supports. Most of them are open source, as Pete has mentioned, and I think this trend open table formats will continue. It just provides so much benefit for the customers. They don't want to be locked in. But there still will be many different open formats. There still will be old data in the proprietary formats, and you can access all of that using Presto, using Lakehouse. So that's absolutely where we are going, I think. And returning back to storage or to the acceleration of the access to storage, you only can enable this technology, this value, if your access to data is fast enough, right? Otherwise, your queries are gonna, you can access any source, but it's slow. It just doesn't work. So you have to have both the acceleration and ability to talk heterogeneous sources of data.
Yeah, yeah.
So,
Very
so
cool.
just a quick question. Yeah, just a quick question there. So, what would you say like some of the technological differentiators are with the HCI solution specifically?
Yeah, so I think the fact that we are using local devices and combine them, however, into a single pool of data, and they do erasure coding across all of those devices, gives us an ability to provide durable cache. So compared to some of the other technologies in the market, one of your nodes dies or one of your devices goes down, and if you were caching in that device, that's it. All of that cache is not available. You might have not lost the data, or maybe you might have not lost you might have lost just the most recent data, which is also not pleasant. But because of the working set size in these workloads is large, just rehydrating, just getting the data back into the cache is going to take a lot of time. And so with our solution, you don't need to bother about that. Another very interesting differentiator is the ability to access the same data through both interfaces, object and file. This is unique. This is truly unique. And why is that important? Right now, we are focusing mostly on Presto, right? And it talks object. But watsonx.data internally consists of multiple compute engines. And in general, customer will run many different engines, data analytic engines on top, which will require a different interface, file or object, but exactly same data. You don't want to duplicate it. You don't want to replicate, have two copies of the data to just access it through different interfaces. So I think those are two. And then the third one I want to mention, and that's something maybe picking a little bit further in the future, right? So I already mentioned that we tuned the stack so that specifically this workload runs really well. But because of we know what kind of data we are storing and providing access to, right? Open table formats, Iceberg is being one of the prominent ones. We can even go further and say, hey, we want to cache these specific portions of files because we know you will need them very frequently for your workload. We can look inside of the files and find references to the other files and objects and prefetch them in storage even before you or Presto realizes that data is needed. So that's another one that is, I think, is very tailored to this important use case and will provide significant performance boost.
That's awesome. Yeah, those are really good ones. That was a great question, Kelly. Okay, so any parting thought? This is a great discussion, by the way. This has been really, really interesting. I mean, I've learned a lot, and certainly our audience is going to learn a lot too. But any parting thoughts, questions, ideas, concepts, things we want to kind of emphasize at the end of the show? Anyone?
So maybe I will quickly go back to one of the points you mentioned earlier about this convergence of AI and data, right? So like, hey, watsonx.ai, what about watsonx.ai as well? And the technology here, the acceleration by smart intelligent caching, right, is applicable for AI workloads as well. And understanding that any AI pipeline requires data cleansing, data preparation. So who is going to manage that data? Well, one plausible and very likely scenario is going to be a Lakehouse. So you have Lakehouse, and then you have a training and data cleaning pipelines on top of that for AI. And so I think the evolution of this architecture as we go forward will have a lot of great potential for AI workloads.
Yeah, I was gonna dogpile on that and say that this is exciting because it's our foray into this whole category of data lakehouse. But what's really interesting is our architecture has legs, and it's going to carry us well into the future and allow us to add a lot of differentiation in the coming quarters and years.
Yeah, and we haven't even talked about the fact that Fusion HCI also provides a very robust and very flexible platform for any OpenShift application. So you can even have co-resident applications that are maybe leveraging some of the data from the AI side of the house. And as we get a little bit farther down the road with hosted control planes, I mean, some of these multi-cluster architectures are going to be really super flexible and super amazing. So it's cool stuff. It's exciting.
Absolutely.
So, yeah.
If you want to hear something really cool in the end, I find it really cool, and it demonstrates how flexible is the platform. So one of our colleagues here demonstrated ability to run serverless platform on top of Fusion, right? And then furthermore, we enable that dual access to data that Scale and Nuba provides. So one piece of the pipeline that was serverless was writing the data using file system, but the other piece also running as serverless was actually using object interface, that same exact data. So I think this is so powerful. You have serverless, you have file system, you have object, and all in one single platform. It's fantastic.
Nobody else can do that.
If you at Red Hat, we actually put together, we were using Ceph object and bucket notifications to trigger serverless processes. So everything you're talking about, it becomes a very powerful way, to fire up processes and then tear them back down very, very quickly. It's really cool stuff.
That's awesome. Well, this has been, again, a great discussion. I mean, super, super cool stuff. It's always fun to kind of get deep into the leading edge technology stuff and talk about some of the advanced capabilities. So Vasily, thanks so much for joining us. Would love to have you back in the future as things evolve and develop. I think I think we'll want to definitely have you back for an update. But thanks so much for joining us. And thanks, Pete. Thanks, Kelly. Thanks, everyone, for watching. As always, if you have any ideas for additional topics, please let us know what they are. This has been a great discussion. We're going to have actually another episode coming up where we're going to go a little deeper into another part of watsonx. So the coverage, our wall-to-wall coverage will continue. So thanks, everybody, for watching. Thanks for joining, and we'll talk again soon. Bye-bye.
Thank you.
Thanks, everybody.